Welcome to the part 1 of three-story reinforced concrete office building analysis and design. This tutorial is for educational purposes only. So this three-story RC office building analysis and design is in compliance with National Structural Code of the Philippines 2015, and the structural design of reinforced concrete was adapted from ACI 318-410M, and the wind calculations procedure was adapted from ASCE 7-10, and the earthquake calculations adapted from UBC 1997. So we will use ETAB software. ETAB software is extended three-dimensional analysis of building system. Then we will use SAFE software for the slab analysis and design. So we will determine the slab thickness and the serviceability requirements using SAFE software before we proceed to building analysis. Kasi, kailangan mo munang i-establish yung slab thickness mo. Kailangan ma-check mo yung slab mo for the elastic and long-term deflection. So, if your slab thickness satisfy the serviceability conditions, then you can start to do the building design. Okay? Then, from ETABS, we can use Excel for the beam design, column design, and footing design. But there is another software called Standard Advanced Concrete Design, RCDC, that's very powerful for the design and detailing of the reinforced concrete members. So also the estimates, bill of quantities, and production of drawings is very easy using Standard Advanced Concrete Design, RCDC. Okay, so we will start. So, gumagawa ko ng manual for this tutorial. Lalabas ko siya pagkatapos ng mga video tutorials ko. Okay, so this is our floor plan. Basically, this is our architectural plans. So this is ground floor level. Okay, see, so we have a garden in the ground floor. So this is the garden. Basically, our second floor, third floor, and roof are open to this area. Okay. So, ang unang gagawin, establish mo yung mga column location. So, framing plans and columnation layout. Yan muna ang gagawin. Okay, so for example, I have this columnation. So, this is a rectangular building. Meron ako ng column dito. Then, yung column ko, gusto ko ay along straight line lang siya. Okay, so this is a basic framing system. So, this is a regular building. Ito yung mga column ko. Then, interconnected siya ng beams. Okay. So, sa ETABS, ganito ang mangyayari sa ground floor. Then, second floor. Second floor ko, ito siya. So, opening itong part na ito. Then, dito sa part na to ay stair siya. Okay? This is the roof deck framing plan. So basically, second, third are typical floor, and we have roof deck. So sa roof deck, meron tayo ng parapet wall. Maybe it's 1.2 meter or 1.5 meter ang height. Then we have roof stair. Okay, so punta muna tayo sa classification of structures. So, unang-una, pag mag-design ka, yung classification of structures ay titingnan mo. So, we have occupancy category. So, refer to NSCP section 103. So, you have this table. So, kaya lang magbasa nito. We have essential facilities. For example, ito. Yung essential facilities, it's so alamin natin yung occupancy or function of the structure. So, sa essential facilities, ito yung mga occupancies having surgery and emergency treatment areas. And ito, structures and shelters and emergency preparedness center. So, yung sinasite ko lang dito, ang gusto ko lang malaman dito ay ang seismic importance factor. Kasi ito, pagka essential facilities, 1.5 yung factor niya. So, gagamitin kasi ito sa earthquake design. Okay? Then, dito tayo pupunta sa special occupancy. So, meron tayo ng occupancy category 1, category 2, category 3, and category 4, and also category 5. So, dito tayo sa category 4. So, basahin na lang itong mga occupancy or function of structures. Okay? Kasi dito, gagamitin natin standard occupancy, 1.0 lang yung seismic factors natin. Seismic importance factor, 1.0. So, but the essential facilities, the seismic importance factor is 1.5. So, mas mataas siya ng 50% yung earthquake design dito sa mga essential facilities. Kasi pag nagkaroon ng, let's say, earthquake, so mas malakas yung design niya. Kasi, ito yung unang isang occupancy niya, structure and shelters and emergency preparedness center. Structure and equipment and communication towers, centers, and other facilities required for emergency response. So, mas malakas ang earthquake design niya. Okay? So, ang gagamitin natin dyan ay 1.0 lang. Then, fast forward, we have a foundation investigation. So, refer to NSCP 303.1. Then, we have a minimum required number of boreholes. So, basahin nyo na lang itong part na to ng NSCP. So, for the area, less than equal to 50 square meter, so we have minimum of 1. Okay? Then, punta na tayo sa design criteria. Gagamitin natin dito sa 3-story natin na office building ay 4,000 PSI for the column. For the beams and reinforced concrete slab, 3,000 PSI. And for the footing is 3,000 PSI. Okay? Then we have a deformed bars, rebar, 10 mm diameter and smaller, grade 40 KSI. So this is 40,000 PSI. Then 12 mm diameter and larger, grade 60 KSI. This is 60,000 PSI. Then for our initial columns, the size is 400 by 400. mm, rectangular RC column. And initial beam is 300 by 450 mm rectangular RC beam. Initial slab thickness 125 RC slab. Okay. So we will have a superimposed dead load calculations for office occupancy. Okay. So for second, third floor area, so for example, we will have vinyl tiles. This is 5 kilogram per square meter. So malaki na yata 5 kilogram na to. So around ano lang siya eh, nasa 2 point something. So ginawa ko ng 5 kilogram, 2.05 kPa. Then we have concrete fill finish, let's say 50 mm. So that is 0.023 kPa per mm thickness. So we will have 50 mm times 0.023 kPa equivalent to 1.15 kPa. Then we will have mechanical duct allowance 0.2 kPa, suspended steel channel sealing system 0.5 kPa, and partition load, partition location, partition subject to change, so we will have a minimum of 1 kPa. So we have a total of 2.9 kPa for the superimposed dead load of the second and third floor area. Okay, so for the roof deck area, so assuming that we will have 60 mm concrete floor topping, sloping, so let's say 60 mm, then ito ay 23.6 kN per cubic meter yung unit weight nito. Kasi ano siya, buhos siya. So, concrete ito. Then, 23.6 times 0.06 meter. So, you will have 1.42 kPa. Then, suspended steel channel sealing system. So, may sealing pa rin tayo sa roof. That is equivalent to 0.5 kPa. Then, waterproofing membrane, let's say that is 0.1 kPa. Then we have a total of 2 kPa for the roof deck area load. Okay? So, ano pa lang to? Superimposed dead load pa lang ito. So, basically, ang self-weight natin ay reinforced concrete. So, 23.6 kilonewton per cubic meter. Then, this is our superimposed dead load. So, 2.9, pag i-convert ko siya sa kilogram, just times 100. Times 100. Okay? So, times 100. So, magiging 290 kg per meter square siya. So, kung imagine mo, mabigat siya. 290 kilograms per square meter. Then, sa roof deck, 2 kPa times 100, this is 200 kg per square meter. Okay? So, tapos na tayo sa superimposed dead load calculations. Area load. Then, for example, we will have a CHB for the perimeter of the building. Kukumpute natin yung line load ng CHB. For example, I have 150 mm thickness with plaster both sides. So, ang floor-to-floor height ko is 3.6 meter. Then, I have beams of 0.45 depth. So, 0.45 ito, assuming. So, calculations ko dito, nakalagay lang is 0.6. So, just deduct the beam depth. So, 3.6 minus 0.6 equals 3 meter yung height ng CHB. So, ito yung height ng CHB ko, 3 meters. Then, the unit weight of the 150 mm thick CHB with plaster is 2.63. So, puntahan ko lang itong table na to from NSCP. Malabo pa. So, ito yung table ng 150 mm thick. So, I have 2.63 kPa per meter. And so, for unplastered yon. So, add 0.24 kPa for each face plastered. So, 0.24 kPa lang i-add ko. But, kung gusto mong i-establish yung thickness ng plastering, you can use or you can compute your value according to the thickness required. So, madali lang. Meron kang unit weight ng para sa plastered cement. Okay, so dito sa case natin, 2.63 plus 2 times 0.24, this is for plastering. Okay, so we will have 3.11 kPa. So, ang line load natin sa perimeter of the building is 3.11 times height. So, you will have 9.33 kilonewton per meter line load. Okay, load natin to sa perimeter of the building. So, this is equivalent to 933 kilogram per meter. So, you can now imagine the quantity of the CHB provided. 933 kilogram per meter. So, mabigat siya. Okay? For the roof deck, we will have a 1.2 meter CHB wall. So, 3.11 times 1.2 equivalent to 3.73 kilonewton per meter. So, mabigat din siya. 373. So, per meter. 373 kilogram per meter. Equivalent na. Okay? So, we have now superimposed dead load, area load, and line load. Then, we will proceed to live load. So, nandito siya sa refer to in SCP table 205-1. Minimum, uniform, and concentrated live load. So, for office live load, we will use 2.4. Okay? So, dito sa office, category 13, we will use other offices. Dito. So, for the call center and business processing, you have 2.9. Then, labis and ground floor corridor, 4.8. Okay? So, we will use other office that is equivalent to 2.4 kPa. Okay, then we will have a wind load for office building project. So, for example, I have a location from Dasma, Cavite, and from the map in the SCP. So, ito yung map. So, medyo blur lang yung picture ko dito. So, 260 kph yan. Then, we will have a consider wind speed at 3-second gust factor from SCP. This is 260 km per hour, equivalent to 162 miles per hour. Okay, then our exposure category C and importance factor 1.0. Then we will have wind directionality factor KD. Mahanap mo sa code dito. So table 207A.6-1 for buildings, main main wind force resisting system 0.85. Then components and cladding 0.85 yung directionality factor kb. Then surface roughness C, open terrain with scattered exposures B or D do not apply. Obstruction having heights generally less than 9 meter. So ito yung gagamitin natin. Next is we will have topographic factor. We can compute it or we can use 1.0. So you can do your own manual calculations here. Meron naman siya dito ng mga formulas. Then gas effect factor 0.85 for rigid building. Then dito sa ETABS, meron tayo ng 12 sets. So ang gamitin natin dito yung set 1 and 2 lang. So we will refer to ASC case 1 using along X, wind along X, which is 0 degrees angle, and along Y, 90 degrees. So the eccentricity for these wind load calculations is 0. So ito yun sa NECP. Ito yung case 1. So along X, this is for 0 angle, and this is for 90 degrees angle. So case 1 na gamitin natin. Okay. Then for the earthquake load parameters, so for example, our site location is Dasma, Cavite. Then the importance factor 1.0 for office building, as discussed. Then the structural system is MRF, so special moment resisting frame. Then our ductility factor is 8.5. Okay. Then the story range of the earthquake is from ground floor to roof deck. Then the eccentricity ratio is 0.05. Time period calculations, we can use method A, but we will use using method B. So our CT is 0.03. Suppose we have a soil investigation report, for example. So sa soil investigation report, bibigay sa'yo ng geotechnical engineer yung soil type. So for now, we will use type SD. For example, that is from the report. Then seismic source type A. Then distance to source, bibigay ito sa'yo ng geotechnical engineer. Then seismic zone factor is 0.4. This is for zone 4. Then we will have near source factor, NA and NV. So A stands for acceleration, then V is for velocity. So sa table kasi, hindi ito sakto. So we will use by interpolation, we will get these values, the NA and NV values. Then for the seismic response coefficient factor, this is CA and CV. This is 0.4 of 0.44 of NA. This is 0.5086 and 0.64 of NB yung CV. Okay. That is 0.9677. Then again, from foundation, again from soil investigation, the geotechnical engineer will give you the foundation solution, that is the foundation system. So for example, they gave us isolated footing with minimum depth of 3 meters below the ground. And net soil bearing capacity, they give us the value of 250 kPa at 3 meters below the ground. Then the factor of safety is 2.5 for dead and live load. Then the allowable soil displacement is 25 mm. Okay? So, yung punta natin tong NSCP 208.5.1.3. So, the horizontal and distribution of shear. So, meron kasi tayo ng 5% na nilagay dun sa earthquake load. So, ito yon, horizontal distribution of shear. So, the design story shear, Px, in any story is the sum of the forces Ft and Fx above that story. So, Vx shall be distributed to the various elements of the vertical lateral force system in proportion to their rigidities, considering the rigidity of diaphragm. So, where diaphragm are not flexible, the mass, ito, so, reinforced concrete slab tayo, so hindi siya flexible. So, the mass at each level shall be assumed to be displaced from the calculated center of mass in each direction a distance equal to 5% of the building dimension. So, pagka in-assume natin na nasa 5% distance yung mass, so magbibigay ito ng torsional sa ating building kung naka-regular building tayo. Then, that will cause more higher value in the reaction and also in the forces that will be developed from the lateral forces or the earthquake forces. Then, dito, meron tayo ng, again, from the section 208.7, detailed system design requirements, from NECP, the requirement that the orthogonal effect be considered may be satisfied by designing such element for 100% of the prescribed design seismic forces in one direction plus 30% of the prescribed design seismic forces in the perpendicular direction. Okay? So, pag naka-static analysis tayo, gagamitin natin yan. Then, the combination requiring the greater component strength shall be used for the design. Alternatively, the effect of the two orthogonal directions may be combined. So, alternatively, ito, the effect of two orthogonal directions may be combined on the square root of the sum of the square, SRSS basis. So, when the SRSS method of combining directional effect is used, each term computed shall be assigned the sign that will result in the most conservative result. Okay, so but sa ating tutorial, since 3-story tayo, mag-static force procedure tayo. So, equivalent lateral force procedure, static analysis. Then we will use 100% along X and 30% along Y. Also, we will do it using 100% along Y and 30% along X. Okay, then punta tayo sa combination of loads. And dito, we have referred to in SCP, section 203. So we have this. So meron dito nakalagay, the most critical effect can occur when one or more of the contributing loads are not acting. So ito pala yung most critical effect in some cases. Okay, so for example, meron tayong dead load plus earthquake load. So pwedeng mas critical siya compare sa dead load plus live load plus earthquake load. Okay? Then we have this basic load combination. So paano siya gawin sa ETABS? So ito, meron ako ng Excel dito. PM na lang sa gusto nitong Excel na to. So ito siya. Suppose I have this equation. So dito muna tayo sa strength design. So sa strength design, for the equation 203-1, 1.4 dead plus 1.4 F. So F is loads due to fluid. So gagawin ko na lang para mabilis i-discuss. So ito yon. So meron ako dito ng dead load, superimposed dead load, reducible live load, roof live load, earthquake static along X, earthquake static along Y, wind along X, wind along Y. So ito yon. Okay, ito yung equation 203-1. 1.4 dead, 1.4 super dead or superimposed dead load. Then 203-2, ito siya, 1.2 dead, 1.2 super dead, 1.6 reducible live, 1.6 live, and 0.5 roof live. Okay, suppose we have this load combo, equation 203-3. So, naging 1 yung live load and yung reducible live load naging 0.5. Then yung roof live is 1.6. So, ito yon. Meron tayo dito ng F1. So, dito. So, meron tayo ng F1L dito. So, yung F1 mo equals 1.0 for floors in places of public assembly. For live loads in excess of 4.8 kPa. So, for public assembly, syempre mabigat siya. 4.8 above yan. So, the F1 is 1.0. Okay? And for the garage live load, so 1.0 siya. Or 0.5 for other live loads. So, for example, I have a residential. So, below 4.8 siya. So, basically, magiging 0.5 yon. O kung meron tayong office dito sa tutorial natin, as discussed from the above, the value of live load is 2.4, then we will have F1 equivalent to 0.5. So, kaya magiging yung F1L natin dito, pagdating dun sa load combinations natin na generate natin dito, magiging 0.5 siya, yung F1. Ang ano ko dito sa assumption ko dito, or ang sa notation natin dito, yung reducible live load, yan yung mga below 4.8. So, reducible live load. And then, itong live load, as discussed, for the F1, 4.8, above, that is equivalent to 1.0 for the F1, kaya magiging 1.0 siya. So, live load in excess of 4.8, 1.0 siya. Kaya hiniwalay ko. Kasi pwedeng sa office mo, office occupancy, meron ka ng reducible live load. Then sa mga lobby or sa ground floor access, pwede kang magkaroon ng 4.8 loadings. So, kaya magkahiwalay siya dito. Okay? Then sa equation 203-4, we will add wind load along X and wind load along Y. Then, makakaroon tayo ng negative values. Okay? So, equation 205, balik tayo dito. Ito yung equation 205. So, meron itong earthquake. So, this is gravity load plus earthquake. But, so, we will use the special seismic load combination. So, dito. Instead of using 203-5, we will use this 203-19. Ang mangyayari dito sa load combinations na to, i-add natin dito yung vertical effect ng earthquake. So, kaya dito, papakita ko lang dito sa NECP 208.6 earthquake load and modeling requirements. So, meron tayo dito ng earthquake force equivalent to rho EH plus EB. So, yung EH is for horizontal and EB is for vertical. Okay? Then, ito yung value of EV. So, EV equals to the load effect resulting from the vertical component of the earthquake ground motion, and is equal to an addition of 0.5 CAID to the dead load effect. So, for strength design and maybe taken as 0 for ASD. Okay, so hanggang doon lang muna yung explanation natin kasi basic pa lang naman ito. Okay, so horizontal and vertical. So, we will use rho as reliability redundancy factor as 1.0, but we can compute it. So, I have an Excel, and I will also do a tutorial how to compute this one, the redundancy factor. Okay, so for now, we will use 1.0. Then, back to load combination. So, nandito tayo sa equation 203-5. So, ito hindi ko na siya gagamitin. Ang gagamitin natin is yung special seismic load combination. So, suppose we have CA 0.509, 0.509, then yung dead load natin dito at yung superimposed load ay mag-a-add tayo ng 0.5 CAID. And we will add the orthogonal effect dito. So, we will have this 1.2 dead plus 0.5 CAID plus 1.0 earthquake along X plus 30% along Y plus F1L. So, ganito yung magiging load combinations natin. Then, ito ay para sa 100% along X and 30% along Y. So, we will have plus 1 plus 0.3. So, ito yung mga earthquake along Y. So, meron tayo dito ng 100% along X and 30% along Y. Then, following to that, we will have 30% along X and 30% along Y. Okay, so ito yung special seismic load combo na gravity load, dead load, plus live load, plus earthquake load. Okay, so punta tayo sa equation 203-6. Ito siya. 0.9 dead plus 1.0 wind plus 1.6 H. So, ang mangyayari dito, meron tayo ng 0.9, so 90% of dead load lang, plus wind along X and wind along Y. Also, we will have a negative values. Okay? For the opposite direction. Then, balik tayo dito sa equation 203-7. We will have 0.9 dead, so 90% dead na lang, plus 1 earthquake, plus 1.6 H. So, ang gagamitin natin dito, yung lower limit ng special seismic load combinations. So, yung 0.9 dead, ima-minus natin yung vertical effect of the earthquake. So, ang mangyayari, balikan ko yung Excel, ang mangyayari dyan, gagamitin natin yung, instead of using equation 203-7 from NECP, gagamitin natin itong 203-20. 0.9 dead, so 90% of dead load is used, minus 0.5 CAID, plus 1 earthquake, 1.0 earthquake, plus 30% earthquake along Y. Then, you will have a factor to the dead load of 0.6 self-weight plus, 0.646 earthquake along X So, nung na-minusan natin siya ng 0.5 CAID for the vertical effect, so ang dead load na lang natin na mag-a-act sa load combination ay 0.646. Then, yung earthquake along X is 100% and yung along Y is 30%. Then, we will have these 4 load combinations kasi yung earthquake natin magkakaroon tayo ng mga opposite direction effect. So, plus 1 plus 0.3 plus 1 minus 0.3 negative 1 plus 0.3 negative 1 negative 0.3. Then, along Y naman, magkakaroon naman siya ng 100% along Y and 30% along X. Okay? Then you can have this Excel. I can send it to you. Just comment your email ad na lang. Okay. Then dito sa allowable stress, ito yung gagamitin natin sa foundation sizing and sa serviceability check of the slab. Okay, so equation 203-8 from the NSCP. So ito yon yung 203-8. Nandito tayo sa allowable stress or allowable strength design. So, wala siyang factor dito. So, pagka walang factor dito, ibig sabihin, 1.0 yon. Okay? So, 203-8, dead alone, and plus F, and 203-9, dead load plus live load, 203-10, dead load plus proof live. So, binabasa ko lang ito. I am disregarding the notation that is not applicable to our building design. That's why I am not mentioning H and F like so. Okay? Then I have this equation 203-11 dead load plus 0.75 live load plus 0.75 proof live. Then we will have equation 203-12 dead load plus 0.6 60% of wind or earthquake over 1.4. So, yung earthquake natin dyan, magiging 1 divided by 1.4 will give you 71.4%. Okay. So, dito sa Excel, na gawin natin, ito yung mga equation na yon. Then, pagka wind, automatic, magkakaroon tayo dito ng acting in opposite direction. So, we'll have negative values also for earthquake. So, ito na yun yung load combinations natin dito sa allowable stress. Then, seismic drift, we will use strength design for an ECP, and wind drift, we will use service load combinations. Okay? Then, that's it for the load combinations. Pero, meron pa tayo dito ng alternate basic load combinations. So, ito naman yung from NECP 203.4.2 in lieu of the basic load combinations specified in section 203.4.1, structures and portion thereof shall be permitted to be designed for the most critical effect resulting from the following load combinations. So, dito sa load combinations na yon, when using these alternate basic load combinations, a 1/3 increase shall be permitted in our allowable stress for all load combinations including wind or earthquake. So, anong ibig sabihin nun? So, pagka meron tayong load combinations dito, including lateral, wind and earthquake, we can add 1/3 or 1/3 increase shall be permitted. So, for example, in the foundation, so binigyan tayo ng geotechnical engineer ng ngayon yung SBC natin. 250 kPa, yung allowable. Dapat pag chinek mo yung soil pressure, not more than 250 siya. Pag ginamitan mo siya nitong load combinations na to, gravity. But, pag chinek mo siya dito, sa may lateral load combinations, including wind or earthquake, you can use allowable of 250 times 250 plus 33% of 250. So, you will have, for example, you will have 250 times 1.33. equals 330 kPa. So, yan yung magiging allowable mo. Safe ka pa dyan. Kaya yan ang ginamit natin load combinations. Ito. Okay? So, this is the end of the part 1. So, sa part 2 is the modeling of 3-story office building. And sa part 3, after ng modeling sa part 2, we will use these load combinations. We will apply these combinations in the model. We will apply loads. We will define all of these applicable loads. We will define this in part 3. So the dead load, we will define it. Live load, earthquake load, and wind load. Okay, this is the end of the part 2. Okay. So you can have this Excel. Papalitan mo na lang siya ng CA value dito. Papalitan mo na lang. Ang ginawa ko, nag-formulate ako nito para pag pinalitan ko to, kasi I have 0.44. So dito, automatic siyang magpapalit na. Para hindi ko na siya iniisa-isa. Okay, just comment your email and I will send this Excel to you. Okay, thank you for this part 1. Thank you for listening to this part 1.